Hey, this is Mr. A, and this is calculus, and this is differentiation, and this is the chain rule. Chain rule here. We're going to be doing this very last thing in differentiation today of the chain rule. Now, we've been doing differentiation for a while. We know the power rule. We know all kinds of things. We know the product rule. We know the quotient rule. And if you ever had a problem like this, what did we have to do before? Well, we had to FOIL this bad boy out. We would have to go 2x plus 1 times 2x plus 1, and then we multiply the 2x times the 2x. We got 4x squared. We add the middle guys, and we end up getting 4x plus 1. And now we can do the derivative of this function, and we're going to use the power rule, and we get 8x plus 4, or 4 times 2x plus 1, and that would be the derivative of this function. We would have to do some sort of dividing or multiplying or something like that, or just use the product rule or the quotient rule. Now, what happens when we get things like this? 5 minus 6x to the 5th power. Do you really want to FOIL all of that out? I don't want to. What about when we have the square root of cosine of x? How do we do that? We can't use, there's no product rule. There's nothing being multiplied in there. What about cosine cubed of x? Are we really going to do the product rule 3 times for cosine cubed of x? What about sine of 2x cubed minus 4? We don't know about these things, and so we have to use what's called the chain rule. So, yo, dog, we're going to be going off the chain on this. And so, how do we do the chain rule? Well, the chain rule is when I have more than one function involved. I have f of g of x. We call this a composite function, but we have more than one function involved. If we kind of come back, do you see how I have 5 minus 6x? That's a function. And then on the outside, I have 2 to the 5th power. That's another function. Here I have cosine of x. There's a function. I have the square root of that. There's another function. I have more than one function involved. And so the chain rule says when you get more than one function involved of this composite function, you have to take the derivative of the outside guy, f prime of g of x, times the derivative of the inside guy, g prime of x. And so we're being multiplied. It's not adding. It's not like the product rule here or anything like that. We're doing the derivative of the outside. So we're doing this derivative of the f function, okay? And then we're doing the derivative of the inside guy, the g function. Okay, and so I want to kind of explain this through a couple different examples. These examples, actually, I'm going to come back to this first example that we just did right here. Now, keep in mind, I'm going to erase this work right here, and I'm going to, we already know what the derivative is. We did the derivative right here. It was 4 times 2x plus 1. And so let's take a look at what is happening here. Now, I have a function right here. Okay, and I'm going to call that u. U is equal to 2x plus 1, right? And I know what the derivative of u is. The derivative of u is 2, isn't it? 2 times dx, okay? So, I'll say it like this. du over dx is equal to 2. So we just use the product rule here, or sorry, the power rule. Now, do you see how here this whole thing of u is being squared, isn't it? And so I can use the power rule here to do the derivative. And so I'm going to do the derivative of this power rule here, which is 2 times u, isn't it? 2 times u, this u goes down to the first power. Then I'm multiplying by the derivative of the inside guy. We know what the derivative of the inside guy it was 2. Now what did we say u was? U was equal to 2x plus 1. And you can see 2 times 2 is 4 times 2x plus 1. Some of you guys might be like, what in the world is he doing with u's and things like that? Let's think of this a different way. Let's think of, don't worry about this function on the inside yet. Just worry about this outside function. We're going to do the power rule. So this 2 is going to multiply out front. So we have 2 times 2x plus 1. And this guy goes down to the first power, doesn't it? Then I'm going to do derivative of the inside guy. Don't worry about the outside guy. So what's the derivative of 2x plus 1? It's 2. 2 times 2 is 4. We have 4 times 2x plus 1. There you go. There was your derivative. So let's do a few more examples. Let's do this example right here. This example, we're going to think of him as the inside function. Okay, so what's f(h) prime of x? We're going to do the power rule, so this 5 goes out front. So 5, leave the inside guy the same right here. He goes down to the 4th power, doesn't he? And then I'm going to do the derivative of the inside guy. What's the derivative of 5 minus 6x? Well, it's just negative 6, isn't it, from the negative 6x. So negative 6 times 5, we're going to clean it up a little bit, negative 30 times 5 minus 6x to the 4th power. And of course, if I ask you to plug in any number, if I ask you to plug in at like at 0, let's say we want to plug in at x is equal, we want to find out what is the derivative of this at x is equal to 0. Okay, well, we're going to plug in 0 for x right here. So we get 5 minus 6 times 0, that's 5. We go 5 to the 4th power. 5 to the 4th power is 625. I multiply by negative 30. And I end up getting negative 18,750. That's a lot. Okay? Let's take a look at this next one. Now, we're going to kind of switch this around. If you remember what we do with manipulating, we have cosine of x, okay, and this is all to the 1/2 power. Okay? So we're going to take the derivative. And so what are we going to do? We're going to do the outside guy. Don't worry about the cosine of x right away. We're going to multiply out, so we get 1/2. We still have cosine of x on the inside. This 1/2 goes down by 1, so negative 1/2. Now I'm going to multiply that by the derivative of the inside guy. What's the derivative of cosine of x? That's negative sine of x. And so we can clean this up a little bit. We have, on the bottom, we have a 2. We have cosine of x to the negative 1/2 power. That's the square root of cosine of x. And who's on my numerator is negative sine of x right there. So that would be the derivative using the chain rule. Let's take a look at this one. So this one, think of your u, or think of whatever your inside function is cosine of x. So this is really saying this, cosine of x cubed. Okay, so when we do our derivative here, we're going to use the power rule. We're going to multiply out by 3, keep the inside guy the same. This 3 goes down by 1, and that becomes 2. Now I need to multiply by the derivative of the inside guy. What's the derivative of cosine of x? That's negative sine of x. And there's my derivative. It's really negative 3 sine of x times cosine squared of x, or cosine x squared. There. Let's take a look at the last, but what about? So here, think of the outside function as the sine. Okay, so think of the inside function as this 2x cubed minus 4x. So what's the derivative of sine of this value would be? Cosine of that same thing. Remember, every time you do the outside guy, keep the inside guy the same. So I have sine, the derivative is cosine. Then I do the derivative of the inside guy. I'm going to multiply that by. So I do the power rule here. And so 3 times 2 is 6x minus 4. And there is my function right there. Is 6x squared, right? 6x squared, because that 3rd power goes down to the 2nd power. My fault there. So that is your derivative. Let me show you 2 more examples. Because I know you all want to see, what does this look like with an e, and what does this look like with a natural log? Now remember, the derivative of e to the x is e to the x. And remember, what's the derivative of natural log of x is 1 over x. Okay? So when I take the derivative of this one, so I'm going to take the derivative of e to this value right here. What's the derivative of e to anything is e to that same thing. So we have e to the 4x squared minus 5. Okay? Now I'm going to multiply by, I got to take the derivative of this inside function right here. And I'm going to use the power rule. So 4 times 2 is 8x. And there's my derivative right there. 8x times e to the 4x squared minus 5. That's it. That's all you got to do. Take a look at this one. This one, well, think about this. We have natural log of x, and he is to the 1/2 power. I always think of, anytime I see square roots or anything like that, I put it into a fractional power right there. So now I'm going to take f prime of x, and I'm going to do the outside derivative first. So I'm going to multiply out by 1/2, keep the inside guy the same. This 1/2 goes down by 1, negative 1/2. Now I'm going to multiply by the derivative of the inside guy. What's the derivative of natural log of x? Well, that's 1 over x. And now I can clean this bad boy up a little bit, right? Who do I have on my denominator? I have a 2 on my denominator. I have natural log to the negative 1/2 power. That's the square root of natural log of x, isn't it? I have another x on my denominator, and I just have a 1 on my numerator. So it's going to be 1 over 2x square root natural log of x. So that is the chain rule. The chain rule is basically you're taking the derivative of the outside guy first, the function, and then you take the derivative of the inside function, and you multiply by each other. And that is the chain rule. See you guys. Have a good day.